Hello, and welcome to this presentation, Getting Started with the CMA180 NRT-Z Measurements. In this presentation, we'll explain how to configure and use NRT-Z series directional power sensors with the Rohde Schwarz CMA180 radio test set. This presentation assumes a basic understanding of directional RF power measurements. If you're unfamiliar with this topic, or if you'd like a brief review, you might want to watch the presentation Understanding Directional Power Measurements before beginning this presentation. The CMA180 radio test set can make directional power measurements using an externally connected NRT-Z series directional power sensor. In addition to making simultaneous measurements of forward and reverse power, the NRT-Z can also make measurements of peak envelope power, crest factor, and CCDF. It can also calculate derived quantities such as return loss and SWR. Directional power measurements are supported in the analog TX, DX, and expert scenarios. In addition to providing real-time display of these measurements, the CMA can also provide statistical results as well. The NRT-Z is connected to the CMA180 via an NRT-Z5 adapter and USB cable. If the NRT-Z sensor is not detected, the CMA will display a warning message when measurements are started. In order to make a directional power measurement, the NRT-Z must be placed in line between the source and the load, with the forward power being defined as power from source to load, and reverse power being defined as power reflected from the load back towards the source. Note that on the body of the NRT-Z, there is an arrow indicating the default direction of forward power. NRT-Z directional power measurements are started by going to the global toolbar and then selecting either the TX, DX, or expert scenario under the Analog tab. The sensor configuration and results are accessed via the Sensor tab. Note that there are two sub-tabs at the bottom of the Sensor tab screen, one for terminating external power sensors and one for the NRT-Z directional power sensor. Let's now look at the NRT-Z Sensor tab. The buttons on the right side are used to start, stop, and pause the measurements. At the top of the screen are the most important measurement parameters, and below these are the measurement results for both forward and reverse power. In the remainder of this presentation, we'll go through both of these areas and explain each of them in more detail. Before making any sensor measurements, zeroing of the sensor should be performed. Zeroing should also be performed if the ambient temperature is changed or after several hours of operation. Zeroing is started using the Start Zeroing button. During zeroing, the RF source or radio under test should either be disconnected or should have its output disabled. An error message will be displayed if power is detected at the sensor input during zeroing. During the zeroing process, pop-ups will show the current status, although the entire process usually takes only a few seconds. NRT-Z power sensor measurements often require no additional configuration. The frequency of the signal to be measured can, however, be specified. In some cases, this will improve accuracy, since it allows correction for very small frequency-specific deviations in the measurement values. An external attenuation value can be provided to account for any external attenuators or any cable loss between the device under test and the sensor input. Attenuation port is used to select which of the NRT-Z ports is used as the power measurement point. Since the sensor absorbs a small amount of power, the forward power measured at the source port will be slightly higher than the forward power measured at the load port, and a similar situation occurs when measuring reflected power as well. All power measurement results are given as current, average, minimum, and maximum values, with selectable units such as watts or dBm. In the forward direction, results can be shown as forward power, peak envelope power, crest factor, or CCDF. And in the reverse direction, available result types are reverse power, return loss, percent reflected power, and standing wave ratio. Note that for each direction, only one value can be displayed at a time. The RF statistics parameter defines the number of measurements that are used to compute statistical values, and this parameter is user-definable. The configuration icon in the right bottom corner of the main screen provides access to measurement settings, including some which are not available from the main GUI. These are separated into 3 tabs: Measurement Control, RF Settings, and Limits. Let's take a closer look at some of these parameters, starting with Measurement Control. In addition to showing the sensor being used, the Measurement Control screen also enables switching between continuous measurement mode and single-shot mode. Repetition parameters configured here can be coupled to other measurement tabs as well. The Peak Envelope Power Hold Time parameter sets the measurement time for peak envelope power measurements, and generally this should be longer than the time between consecutive signal peaks. The default hold time of 60 milliseconds is appropriate for measurements of signals having a frequency of 20 Hz or more. And finally, the direction parameter defines the forward power in terms of the port numbers printed on the NRT-Z sensor. By default, forward power is defined as power flowing from port 1 to port 2, but this can be switched to the opposite direction through this parameter. It's also possible to set the direction to auto, in which case the higher power is assumed to be the forward power. Most RF settings are available from the main GUI, but some advanced parameters are only available from this dialog. The resolution value is used to select the measurement resolution. Higher values increase accuracy, but will also increase overall measurement time. Bandwidth defines the bandwidth of the so-called video filter. Smaller bandwidth settings will decrease the contribution of noise to the measured power. But it's also important to ensure that the video bandwidth is at least slightly higher than the bandwidth of the measured signal, since otherwise envelope distortion may occur. Checking the attenuation state box will cause measured power values to be corrected by the entered attenuation value, and the CCDF threshold value is used for defining the probability that envelope power exceeds a given value. The last tab is Limits, which can be defined for each measurement type as upper and lower thresholds in both the forward and reverse directions. If any measured value exceeds one of these defined limits, this value will be displayed in red. For example, here we've defined a limit of 50 watts for forward power, and the current measurement is displayed in red since the measured value exceeds this limit of 50 watts. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set can make directional power measurements using NRT-Z series directional power sensors. These sensors are connected externally to the CMA over USB using the NRT-Z5 adapter. As with most RF power sensors, the NRT-Z should be properly zeroed before making measurements. The NRT-Z allows simultaneous measurements of both forward and reverse power, and this includes envelope measurements such as peak envelope power and CCDF. Furthermore, the combination of forward and reverse power measurements allows calculation of parameters such as return loss and standing wave ratio. All results can be displayed in real time as well as statistically, that is, as minimum, maximum, and average values. And although the default values are suitable for most directional power measurements, all measurement and display values are also user configurable through the CMA's graphical user interface. This concludes our presentation, getting started with the CMA180 NRT-Z measurements. If you'd like to learn more about power measurements, other radio measurements, or about power sensors and related instruments from Rohde & Schwarz, please see the links in the video description.
Thanks for watching. Please subscribe to our YouTube channel and visit us at rohde-schwarz.com.